Okay, so we want to begin our learning on one of the final non-parametric tests, actually. Is known as independent ANOVA. Independent ANOVA. It is used when the data set is normally distributed, the data is continuous or ratio, when the groupings are categorical, and when there are separate variables across the groups. So you can have regular MBA, weekend MBA, executive MBA, when the sample size are randomly taken and the spirit of homogeneity of variance for the dependent variable exists. So it's basically like the two sample tests, but the samples here are 3 or more. So 3 or more samples. And so the way you formulate the null and alternative hypothesis is the same as the t-test. The way you formulate the hypothesis are the same. The steps in hypothesis are the same. The first step in hypothesis testing, if you can remember very well, is to formulate the null and the alternative hypothesis. That's usually the first step in hypothesis testing. The second step in hypothesis testing is to calculate the test statistic as well as a critical value, and then you compare the two of them. Now, this independent sample is different from the dependent sample. The dependent sample is like the one you've seen here, where the subject is the same. So you have this sample 1, you have the sample 2, all the way up to sample 4. But the first observation, those are its values. The values that you see is for the same person. It's the same person who is repeatedly taking drug 1, 2, 3, and 4. And because the subject is the same, even though the samples are different, this is known as dependent sample. And therefore, it requires dependent ANOVA. This dependent ANOVA is just what you might call the F test. Just like the two sample, we call it dependent or paired t-test. So you realize that there are quite some interesting letters we use for them. You have the t-test, you have the z-test, you have the u-test, you have the w-test, we have the f-test, which is what we're going to do. So let's try to take a particular example of a data set and try to formulate the hypothesis. Like I said, formulating the hypothesis is very simple. For ANOVA, the hypothesis is always the same. The only thing that changes is based on the sample size or based on the sample groups. So if there are 4 groups, the way you formulate will slightly differ from 7 groups. But approach is the same. The approach is very the same. For example, if the groups are 3, the null will always be mu1 equal to mu2 equal to mu3 equal to mu4. That is if the samples are 4. And the alternative is always this, okay, that a mu I is not equal to mu j for at least one, okay, I don't want to write the other, for at least one I or j, for at least one I not equal to j, where I or j is equal to, in this case, 1 to 4, because there are 4 samples. Now, if the samples are not 4 and they are 3, the only thing that is going to change is just this removal in the null hypothesis. If the samples are 3, you remove this and you change this 4 to 3 because the samples are 3. Now, the reason why you use this one instead of the not equal to symbol, okay, for all of them, you don't want to use mu1, mu2, mu3, all of them not equal to, not equal to, not equal to. The reason why we don't use that is because you just need one of them to be not equal to. You just need one to be not equal to nullify to nullify the null hypothesis. So just master how to do it. It's very simple. It's kind of automatic, and you have to learn how to write the null and alternative hypothesis. Anytime you're doing ANOVA, it requires that you have a table called the ANOVA table, which you create. We'll talk about that in the process. We're going to use this very story here to learn about ANOVA, basically. So you see the salaries in thousands of Ghana cedis for 3 different MBA groups. So you see the regular MBAs are earning 1,000 all the way to 3,000. The weekend MBA are earning 4,000 all the way to 6,000. The evening MBA are earning 7,000 all the way to 9,000. The question is very simple. Define the null hypothesis and the alternative hypothesis. Find the critical value, find the test statistic, decide and conclude. Decide and conclude. So let's go back to the data set. I will encourage all of you to please write the data set in your book. Write a data set. Now, from hindsight, they are told you there are 4 sides to the human body, to the human eye. There are 4 sides. You have the hindsight, okay? Then you have the oversight. And then you have the foresight. And finally, you have the insight. Each one of them. But then, from hindsight here, you are likely to conclude that which group is earning the highest salary. From hindsight, you can tell me which group is earning the biggest salary. Nancy?
EMBA.
The EMBA, exactly. Okay. Now, it could be that this is just by chance, by hypothetical. Until you subject this to statistical torture, you cannot conclude that that's the case. Because in real life, things are not as simple as it is. So what we're going to do is to, first of all, subject this to statistical torture. And then we can prove whether or not the EMBA earns the lowest or otherwise. Or whether they earn the highest or otherwise. So first thing you got to do is to formulate the null hypothesis. Now, looking at this, who can formulate the null hypothesis for me? Who can guess how to formulate the null hypothesis? See, one thing about ANOVA, I told you, you don't need to write it before you determine what the null hypothesis is. You can just start straight away and mention what the null hypothesis is. Jimana?
Yes, the null hypothesis will be mean 1 equals to mean 2
Mu 1
to
equal
mean
to
3.
2. Yes.
Mean 2 equals to mean 3.
Uh-huh.
Then the alternative will be mean 1 not equal to mean 2 not equal to mean 3.
I think you've missed it because we said it some few minutes ago that you have to say that mu I not equal to mu j.
Mean 1.
All right, you've done your part. It looks like you are not paying attention at all. So you have mu I not equal to mu j, okay, for at least 1 I not equal to j, where ij is 1 to 3. Okay. 1 I not equal to j, for at least 1 I not equal to j, where ij equals to, where ij, let me rewrite this. For at least has to come. I don't want to write that. Okay. Where I or j is either 1 or 2 or 3. Master how to write a null hypothesis. But I'm more interested in you telling me what the null is saying, actually. Who can tell me what is this authority, by the way? What is a null trying to say? What does a null mean in English sentence? What is the implication of the null? What is a null saying? The null is saying what? These are the salaries of different MBA groups. So what's the null saying? Null is saying that there is no difference in the salaries. Okay, no difference in the mean salaries across these three different MBA groups. There's no difference. The alternative is saying, hey, hang on a minute. At least one of them is different from the other. The null said, no, there's no difference. There is no difference in the mean salaries. So we've got to check whether that is true. And to do that, as you know, in step 2, we need to find the test statistic. In finding the test statistic, we are going to create the ANOVA table. The ANOVA table is a very fine table, and I want you to be doing the table, writing the table, whilst I also write the table. So please, ANOVA table is what we are going to write. You have to create this table. So this is how you go around it. You write this, and at the top, you write source of variation. Source of variation. Then the next thing you want to write is the sum of squares, then the degrees of freedom, then the mean square, and finally the F statistic. The first section of the source, you're going to look at the between group variation and then the within group variation. The between group and then the within group. Now I want you to cast your mind back to the data set. You will notice that when you take RMBA group alone, which is the within, there are differences. When you take not the RMBA group, but you take between the RMBA group and the MBA group, you will notice that there is a difference. But even within the RMBA group, there's a difference. So what this is looking at, the first row here, the second row, is looking at the between group variability. So we're going to use that to calculate the between group variation. Then we will also calculate the within group variation. And then we'll use the two, find their ratios of their mean squares, calculate the F statistic. So we need to find the variability, the sum of squares, because it's from the sum of squares that you're able to find the mean of that square and then find the F statistic. Now, the F statistic that you are seeing here is actually a formula. This F statistic looks at the group mean square, okay, is a ratio of the group mean square, which is called MSG, divided by the MSW, which is the within group mean square. That's what we are going to find. But to do that, we need to know the SS. The SS refers to the sum of squares. This sum of squares is given by, in here, below that, because it's for the first group, it's called SSG, which is a group sum of squares. It's read from backward to left, group sum of squares. And this group sum of squares is a formula which looks at the sample size, okay, the sum of the sample size. Then you have xi bar minus x bar all squared. So this is the formula that you have to be able to calculate the SSG. Now you can see that here in the formula. But what does this mean, basically? Well, the NI is the sample size in each group. So who can tell us, remind us of the sample size in each group? NI. What's the sample size in each group? You all wrote the group, right? Yes, Nancy.
3. 3.
3. The sample size is in group is 3. So that means that the sample in each group is balanced. So there's a balanced sample. Please note that it's not always balanced. It's not always balanced. So that's the first thing we are going to find. Okay. Then we take the mean in each group. This xi means that you are calculating the mean in each group. And this is a grand mean, the mama mean. So you take the mean in each group divided by minus the grand mean, you square it. And then you multiply that answer by the sample size. That is what you get. You are going to do that, and then you add all of them for each group. Now, if you remember the data set, let me try and see if I can remember the data set. So this is a data set. So if you take group 1, you have 1, 2, 3. Group 2, you have 4, 5, 6, and then on and on. You're going to take the sample in the first group. Okay. Yeah, Ruby, your hand is up. Okay. You take the sample in the first group. I'm picking it from here. Okay. So the sample in the first group, that's 3. So you take this 3, you bring a bracket because the formula says that there should be a bracket. You take the mean in this group. So you got to go calculate the mean in each group. What is the mean in the first group? If you check it carefully, the mean, which is a x1 bar, that's how it works, is going to be 2. In fact, if you're not sure, do 1 plus 2 plus 3 divided by 3. And that will give you the mean, which is 2. Now, the next one, what is the mean? The x2 bar. You can tell us.
5.
5. Very good. And then the last one.
8.
8. Very good. So you got the means. But when you're calculating the grand mean, which is an x bar, take note, you don't need to add the 2 plus 5 plus 8. No, that's a wrong approach. It will work in this case because it's balanced, but in real life, it's not balanced. So how do you calculate the grand mean? You have to add the 1. I want you to know. You add a 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which is 45. So it's going to be the 45 divided by the total sample, which is 9. What do you get?
5.
So you get 5. But remember that that 5, that's exactly the same answer you would have gotten if you had added the 2 to the 5 to the 8 and divided by 3. But that approach would have been wrong. It only matched this 5 because the sample was balanced. But in real situations where it's not balanced and you can see an example, you will notice that that doesn't work. So that is a 49 divided by 5. Who is not clear? If you're not clear, then I know what to do. Excellent. Now, with that, we've gotten that we are going to go back to the formula. The formula says that take the sample in each group. So you got a sample in each group to be 3. Take the mean in the first group. The mean in the first group is 2. So you get 2 minus the grand mean. The grand mean is 5. You square it. Then you bring plus. You go to the second group. The sample in the second group, that is 3. Bring a bracket. The mean in the second group, that is 5. The grand mean is 5. So 5 raised to the power, to the power 2. Okay, you do that. Then plus the last one. The last one is the same 3 into bracket. The mean in that group is 8. 8 minus 5. Okay, then you square it. So you now add all of these. Do that and let me know your answer. You got to be just participatory. Yeah, what do you get? You should get a value of, I know the
54.
answer. It's 5,4, exactly. So when you come to this section here, for the first SS, the value you are supposed to get there for that first SS is 4. That's what you get, 54. Now remember that I have my table. I don't want you to get confused with the table I wrote. So it's something like this. So the value, the value you get here is 54. That's what you get. Now we are left with this section here in this box. What value are we going to get? And it's called the within group sum of squares. Within group. Now look at it. The within group means that you are going to take each group and analyze the differences there within. How do you do that? Oh, trust me. So simple. So simple. So you clean this one. Let's clean this one. And then we go to the board. Go to the board. We need to find the formula for finding the WJ. It's actually known as SSW, the within sum of squares. What formula do you use to get that? Well, this SSW is given by double summation. Summation Xij minus Xi bar all square. We bring the Xij minus Xi bar all square. I just want to show you that here. That's the same formula you have here. Yeah, Tina. Tina J, your hand is up. All right, I think that was a mistake. So this is the formula. I just want to show you again the formula. So we're going to take the Xij minus the mean in each group. Now, what is the Xij? The Xij is each of the numbers in each group. Each of the numbers, write it down, in each group. That's the Xij. Each number in each group is Xij. Each number in each group. Now, because the groups in this case are 3, we have to find the SSW for each group before we add them. That's why the summation sign is double. Double means I first find them. And in finding them, you have to do some additions. And then finally, add them. So I'm not going to the data because you all know what the data is. It's 1 all the way to 9. 3 in each group. So how do you solve for this? It's simple. Let's take the SSW1. Let's assume that I want to find only for the SSW1. 1. I will take the samples in each group. The first number in the SSW1, the group 1 is what? The first number. Yeah? 9. 1. So that is a number that will be here, minus the mean in that group. What was the mean in that group? 3. So you get 1 to 3. That's what you get. 1 all the way to 3. That's the value of what you get. And then you have to bring the square, sorry. Yeah. So you do 1 to 3, you square it. Plus, you go to the second number. The second number is 2 in that group. So you do 2 minus, sorry. The first one, the mean is 2. It's not 3.
Yeah, the mean is 2.
Okay. I know majority of you are not yet paying attention. Okay. Well, 1 minus 2, then you square it, plus the next one is 2 minus 2, you square it, plus the last one, you get 3 minus 2, and you square it. So do that and let me see. Next time, what we are going to be doing is regression. We're going to start regression analysis, and then we'll start running it. Ladies and gentlemen, that brings us to the end of the entire Kabuto. Maybe if you have a question, please. For me, I knew that your class is a class that never talks. So I've made up my mind that I will also never.
Fine.
Yes. I'll never push you. Any question? The EMBA class, they communicate a lot. They are different when you are teaching them. Really, really exciting, different.
Prof, at the point your line was breaking, so
if it was breaking, Anka, you'd have said it. You would have said so at the point my line was breaking at that time, and then they see an map. So next time you say it was I'm teaching, not when I'm done. You can even type. All right, no question. I wish you all the very best, and I'll see you exactly next week. Have a wonderful afternoon.
Thanks so much, Doc.
Okay.
God bless.
bye.